Okay, we should be live. Just testing my sound as per usual. And making sure I'm using the correct microphone as well. Might want to give a bit more volume to the microphone. Just keep it in the right range. Okay, so that sounds okay. Yeah, we finally got to 1,000 subscribers on YouTube. Thank you very much for following along. So hopefully we can make even better content for you. Should we start with which bot should we start with? Any suggestions? Okay, we now have yeah, it's some YouTube stuff. No one cares. That's not what you are here for. Just still setting up my stream and stuff like that. Give me a sec, and we'll get going with this EEG recordings, EEG data, pre P300 data visualization. Get to that hopefully very quickly. Okay, just sharing the stream on LinkedIn as well. Hopefully someone joins in and actually asking questions. Eventually everything we do on this channel appears on the website bionichaos.com. Go check it out. You can search through EEG, ECG, biomedical imaging, vision, hearing, mental health, whatever. That's kind of future topics. Yeah, lots of simulations, web applications that actually simulate the process, review, visualize biomedical data, and the relevant stuff as well. Yeah, for example, this joint time frequency scattering. This one can help for detecting, better detecting seizures in EEG time series signal. This should have all the code, because people keep asking about the code. All the code should be on the website. So if you go F12, you should see the HTML, and in this case the HTML also includes the JavaScript. So the processing is happening in JavaScript. So generating the spikes, generating the EEG, synthetic EEG data. We have an actual function calculating FFT. So we don't actually need the library. We were, for another application, we were actually using a library, an FFT JavaScript library, but we don't actually need it. We can implement yeah, that's pretty much it. It's was it 15 lines of code. You can do your own FFT, your own frequency processing. Yeah, we cut out the low frequency, removing baseline drift. It's actually what you see. Yeah, the signal is drifting quite a bit. It's a bit all over the shop. Yeah, we have these events for the P300. They're essentially these blobs of red and the blue squares on the screen, which are meant to only hit the space bar when it's red. So you have these events. Yeah, there's obviously more events than just the two, so I don't know what's up with that. I had a video of the experiment, but that's only showing two types of events. There's, yeah, we might ditch this data because it doesn't actually have the codes, the definition of what each event is doing. Anyway, I was just saying, the main struggle with that code is that we were trying to, this FFT here is done by a JavaScript library, but then we don't actually need it because we have our own. Well, I mean, it's working, so we might as well leave it there. We might as well leave it there. Yeah, so you see there's quite a bit of it's the 60 hertz. Yeah, there's that 60 hertz. It's now a flattened 60 hertz there, but there was no 60 hertz to begin with. There was 50 hertz. Actually have to change and refresh. Yeah, it's getting rid of it. The filter is ringing, so I have to be careful. You can see the beginning and the end of the time series. There's quite a bit of fairly obvious ringing. I wonder if the robot will be able to pick up on that. Yeah, we got a metadata. We got 8 channels, microvolts. Yeah, not much to it. We have this bunch of events, time domain. We also have accelerometer. And in this case, if you look at whatever channel 1, 2, 3, doesn't matter. They seem to have this, yeah, huge baseline drift that's quite significant. So supposedly, if the subject is only moving when they hitting the space button, every time they move there, they essentially saw a red a red square on the screen, and then we should be able to correlate it to the EEG. The analysis they did, in the video, in the YouTube video, is not good enough. Yes, we got this data from the Mental Lab website. It's they seem to have a very good device. I haven't tried it, so I won't be endorsing it in any shape or form, because I haven't actually seen it in flesh. But interesting, and that indicates how good this company is that they actually published some of the raw data on the website. They have a video of the experiment. Someone doing the experiment. Yeah, it's flashing this light while recording EEG. Standard stuff. And then they are showing they're showing these results. So this is the 8 electrodes. There's actually no labels. Yeah, we can assume. Yeah, we can assume this type of mapping. So channel 1 to 8, and then we have the reference. Yeah, like the markers for each event don't actually have a description of which marker is which. But yeah, ChatGPT very kindly made the code for us that now we will be splitting into separate JavaScripts. Because currently it's a whopping 500 lines of code. Yeah, so the filtering works okay-ish. Yeah, we have this huge, because of the huge baseline drift, we don't see anything, because the low frequency component is overtaking over everything. If we remove baseline, we remove baseline, yeah, the signal is centered around 0. But that doesn't solve the drift, does it? Because you can see from the time domain we have this DC shift over time, a DC drift. So that's not nice. Anyway, just the first impression of this, it's like, yeah, my understanding is the device is very good. However, so you have this yeah, have this device. It's working real well. It's streaming data remotely, wirelessly to another dongle that you just collect via USB-C to your laptop. So that's all working really well. Well, problem is that yeah, you can over-engineer your recording device and stuff, and that's working really well, but you cannot. The bottleneck with this recording is seemed to be the electrodes. So in the impedance measurement, they say that each electrode had below 5 kilo, but in my personal opinion, 5 kilo ohm is not enough. It should be below like 500 ohm or so, the impedance on each electrode. So essentially the electrodes are not making great contact with the skin. If, yeah, they're making some contact. I don't know how they normally replace like conductive, fill it with conductive paste and stuff like that. So that wasn't done. They interestingly still see some P300. It could be, however, an artifact of someone clicking the spacebar, because that's what they have to do. So essentially, it could be that the accelerometer data, it's when they actually hit the spacebar, supposedly after they saw a red square, could actually be correlated to this response in the EEG. So essentially a motion artifact. You don't see any artifact in one of the electrodes, but I think there's just something wrong with it. So you see a response, a non-target response. So supposedly only on target they actually pressed the button, the space bar on a keyboard. When there was no target, it was a blue square. They didn't press anything at all. So supposedly the blue response is actual brain activation seeing the image. That's supposedly what meant to happen. But again, you just have to do a very, very careful analysis, actually determining what's going on. But in essence, it's showing that yes, on some channels, some recording positions, you have more response when target. But again, that additional response, yes, you could have some visual response from them seeing something flashing on the screen. Again, could be an artifact of that screen. I've seen things like that before. And then the actual target response, this is also when they click the space bar on the keyboard, could be an artifact of the subject actually moving. But yeah, the response there is not, we're talking microvolts. And yeah, we also have to look at, in the location on the brain that was responding most, if that's a response even significant, or we're looking at noise, how many repetitions were done. There's a few things that don't really make sense about this data set. For example, the market data meant to be a binary, meant to be a blue square or red oval or something. But obviously they have more markings. Maybe some of them is actually when the subject was clicking the spacebar, but that's not described in the dataset. This all we have essentially on the dataset, number of channels, and yeah, EEG 8 channels, event markers indicating. So this is just stimulus onset. So essentially those markings, events, there will be different stimuli presented. So there was essentially not just blue and red, there was something else as well. And we don't really know what it was. FFT, yeah, works okay once you filter the thing. It's 50 hertz because it's somewhere in Europe, not the American 60 hertz rubbish. And you see the responses there. So if you don't filter, yeah, you still see it. So that's fine. We actually have to make sure we're applying it to all the data. So in this case, you have the stimulus onset and then the response after stimulus, but this is all of them being overlaid. 50 hertz is in the DC shift, so it's not centered around 0. So this one we can fix, but yeah, wondering primarily, actually forgot to transcribe my speech, because that's what I normally do, and then we pop it into back into the LLM. The LLM is a co-host or the main host, depends how you look at it. Yes, again, so this is where the data set is from. They don't have much details. The video is also not very detailed. They're showing this result figure that we essentially are trying to replicate, or ChatGPT is trying to replicate. We have the locations of the electrodes. I assume they mapped in the same way, so the order TP9, CZ, CP1, CP2, PO3, PO4, OZ, BZ are correlated the same order, so electrode 1, 2 to 8. So we are happy to make that assumption. Yeah, we can mention somewhere in the metadata that all the electrodes had less than 5 kilo ohm impedance. Kilo ohm. That's right. Yes, we got the locations, the impedance. It looks good. There is, however, another thing is that for the events, yeah, I want to analyze the events a bit further, because the video, the information about this experiment suggests that there are 2 types of stimuli. However, in reality, looking at the marker data, there is more, because there's SW8, SW10, 11, 20. I think that's pretty much it. So there's essentially just 3 of them. But again, I was expecting only 2. So maybe one of them is... No, wait, we have 1, 0, 2, 0, 1, 1. Looks like a binary coding of some sort. Then we have 2, 0, which is obviously non-binary. Oh, and SW8. Yes, so we need to investigate more into what's happening there. Now in the time domain, okay, so in the filtering, we need to make sure that when we change the filter, when we apply the notch filter frequency 50 hertz, and removing the baseline drift, we wanted it be applied in all the other tabs as well. So that's kind of very important. Yeah, again, so we need to go over the market data to investigate why there's more than 2 labels. There's like 4 of them, I think, but yeah, if you can double check. And yeah, do like we can do a distribution of each label, because currently we have the event distribution over time. We also need an event distribution for each label to see how many of them are being presented and how often. Yeah, in the EG epochs, so we currently have all channels. There's something happening, something up with channel 5 to 8. I think we're not actually loading the data properly. Again, as mentioned before, we need to make sure that the filters applied in the filter tab are also visible in the EG epochs tab. In the metadata and details, we can actually specify that all the impedance for each electrode is below 5 kilo ohm, as discussed. And yeah, and I don't particularly mind if we keep the code as is in one long HTML file, as long as we can actually edit it all and generate the complete HTML. So I want you to, address all these concerns and regenerate the entire HTML from scratch without removing any current functionality. So currently the HTML is more than 500 lines of code, including the JavaScript. So I assume you can regenerate it without any placeholders. And what else? Yeah, it seems like we're only loading the first 4 channels instead of the whole all of them, instead of the 8 channels. And same for the accelerometer data, the ORN data. We have some other stuff in it. So we have the AX, AY, AZ, but we also have gyro. And yeah, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 channels in the ORN data. So we might want to at least view it all. And eventually in the EG epochs, we want to be able to, well, yeah, once we remove the noise, we'll see it better, but we also want to be able to select just a single epoch as well. And for each epoch, when we're selecting each epoch, yeah, we want to know which stimulus was shown. So that's kind of very important as well. I don't know if you want to comment first or go straight away generating the code. Your choice. Okay, so we are using all three mini high. Yeah, I'm not sure if it was suggesting to split the JavaScript, but I don't know if we have to do it at all. I mean, if it can generate like 1,000 lines of code or whatever, we don't care. It shouldn't go over, shouldn't be too long. And yes, while it's reasoning and generating stuff, hey, go check out the website. Eventually everything we do appears on the site. Yeah, it's generating all the code. Yeah, it's pretty amazing, and it's reasoning and everything. It's a pretty amazing job. Yeah, in this case, we are using an FFT JavaScript library. We're not doing our own FFT. Okay, 758 lines of HTML. That's still the previous version. Okay. Why channels 1, 2, 3? Channel 5 is not working. 6, 7. Yeah, there's no data. Yeah, this data set. This data set is not great. So we're missing. Actually missing the potentially, yeah, very important the data there. Yeah, the data set is incomplete. Wait, Let me check EG. Ah, yeah, you can see it straight away. Actually, from the CSV, I didn't actually need to plot it at all. Yeah, there's no data for 5, 6, 7, 8. Yeah, so kind of useless. Ah, yeah, which I think just wasted that time. So we cannot reproduce that. It's essentially only half the dataset is present. I don't believe it's to do with how we download it or anything like that. Can download it again. Yeah, there's no data. Channel 5, 6, 5 to 8, it's only half the data is present. Not good, not good. Events. Yeah, this is the histogram for the events count label. So we have this SW10 is happening a whopping 200 times, whereas 8 is happening 10 times. I don't know what it is. 11 is happening 50 times. And 20 is happening 50 times. So obviously it's like predetermined. So I guess SW10 is nothing, and these two are targets or the controls. So in theory, from the video, yeah, it's only clear that you're only doing 2 of them. Yeah, doing this blue square and the red oval. There's only 2. In reality, there are 4. So again, can't really use the dataset. It's quite bad. Yeah, I was expecting more. I don't know why. It's generally surprising that the company will provide you like any data like this in the public domain and have a YouTube channel and everything. But then, yeah, if you do that, you might as well do it properly. Yeah, I think we just wasted some time. Are they even 8 electrodes? 1, 2, 3. Two. Looks like there's only 4. That's actually, yeah, that would be. Well, they say it's 8. I'm pretty sure I know what's up. I suspect these are differential. So normally what will happen is if you have actually 8 electrodes, you only have 8 channels. So that's not this would be incorrect. I don't think this data is actually 8. what's called they are the differential, not referential. So essentially, the bot will know all about it, wouldn't it? Are we still transcribing? Maybe it can just make comments and make it explain the difference between referential and differential. Essentially, we are missing half of the channels in the dataset, and I suspect it's because they actually the recording, well, the data is stored differentially, whereas the analysis was made referentially. Can you explain and suggest your and tell me if I'm correct or not? Don't mind you being very critical. So why sometimes I cannot actually see the reasoning? I can't click on it, so it's reasoned for 12 seconds, but it's not actually giving you the reasoning. But it gave quite the extensive response.
Your observation is quite plausible. In many EEG systems, the way signals are recorded and then exported can lead to situations where only a subset of the channels appears to have meaningful data. Here's what might be happening and some points to consider. Tahir's differential versus referential recordings. Differential recording. In a differential setup, each channel is actually the voltage difference between two electrodes. For example, if you have 8 physical electrodes and you record them differentially, you might actually compute differences between pairs of electrodes. This means that the exported data might only include the differential values rather than the raw voltages from all electrodes. With referential recordings, every electrode's potential is measured against a common reference electrode. In this case, the reference electrode often does not provide an independent signal for analysis. Why only half the channels? 1. Exported differential data. If your recording system was configured to record differential signals, it's possible that the exported CSV only contains the computed differences. For example, channels 1 to 4 might represent the differences between electrode pairs, while the individual electrode values or the reference channels aren't exported. This would explain why channels 5 to 8 seem to lack data. 2. Configuration or montage setup. Sometimes the acquisition software is set up so that one or more electrodes are used solely as references. If the software then exports only the active channels, i.e., those that are not the reference, you might see fewer channels than the total number of electrodes attached. 3. Hardware-software specifics. The system might be using a specific montage or wiring scheme where only a subset of channels, say 4 differential channels, is actively recorded or stored for analysis, even though 8 electrode connections exist. The documentation or metadata might indicate this, but sometimes it's not very detailed. What to do next? Check documentation. Look for any information in the meta file, accompanying documentation, or the device manual that explains the electrode montage. It might explicitly state which electrodes are used for differential recordings and how the channels are assigned. Verify wiring setup. If you have access to the experimental setup details or lab notes, confirm how the electrodes were connected. Sometimes a photo or diagram of the electrode cap can clarify whether, for instance, channels 1 to 4 represent differential pairs, and the others are not meant to carry independent signals. Analyze the marker and event data. Since your event analysis indicates multiple labels, like S10, etc., it might also be that the experimental protocol uses only a subset of channels for stimulus presentation or response recording. This sometimes goes hand in hand with using a differential recording strategy. In summary, your suspicion is likely correct. The dataset may indeed be recording in a differential mode or using a montage that only exports the differential channels, so that in practice, you only see data for half of the electrodes as independent channels. This is common when the reference is subtracted out or when only the different signal saved. It's important to confirm this with the device's documentation or experimental notes. If the experiment was designed to use a referential montage instead, then this discrepancy could indicate an error in how the data was exported or pre-processed. Either way, verifying the intended electrode montage is key. Let me know if you need more detailed guidance or further assistance with interpreting your setup.
Yes, no, the thing became highly unresponsive. Okay, the HTML actually became highly unresponsive because we are now modifying, I guess, because of the filtering tab. When we change something, it meant to modify the rest of the data. Became highly unresponsive. That's right. So it's not very useful. But don't worry about it for now. Can you also explain the image attached? So this is the event codes counts per label. Can we actually yeah, actually do go back to the code, and in the event distribution over time, we want each event code in a different color. So within, so say whenever we have 20, 22, 21, whatever counts of events per time window, I think it's 10 seconds. We want to actually see the distribution of each event label, so we know how many of each are appearing per specific time window. So hopefully that shouldn't be too difficult. And also, yeah, well, considering we don't have the AVA for channels, we want to make a note about it in the metadata details tab. Yeah, make a bold note that essentially channels 5 to 8 are missing, or they just have the same value in the data, so essentially no data. And what else? Yeah, we need to make sure somehow, yeah, when we adjust the filtering, that we can do it for the all the rest of the data, and the thing is not lagging. So it's not become, currently it's became, from your last update, it became highly, it became super slow, the whole web application, and it's not actually completing. Oh, I'm potentially getting a error message as well. Yeah, there's a lot going on. The point is, yeah, that we need to update the code. Yeah, I'm getting this error as well. Okay, how do we make sure the page is not locking up? Would it actually work, or do we need the downsampling options to downsample the data? Okay, can we fix everything and write all the necessary code from scratch?
Movies, oh my gosh, I just absolutely love them. They're like time machines.
Below is a complete final HTML file with the following improvements. Downsampling and zero padding for FFT. Before running an FFT, the code now zero pads the data so that its length becomes a power of 2, without discarding any samples. This prevents the FFT size must be a power of 2 error. Global filtering and replotting. The Apply filters and replot all button down samples optionally removes baseline drift and applies a notch filter, using FFT, for each channel. The FFT operations now work on zero-padded data. Color-coded event histograms. The Events tab now shows histograms for each event code in different colors. Meta details note. A note is added that channels 5 to 8 contain no meaningful data. Simply save this file, e.g., index.html, in the same folder as your CSV files and open it in your browser. Zero padding before FFT. In both the notch filter loop, inside apply filters and replot, and in apply FFT and filters, the code computes a padded length, using math.pow, 2, math, ceil, math, log2, original n, and pads the signal with zeros if necessary. This ensures that the FFT size is always a valid power of 2. Downsampling option. A drop-down, with ID downsample select, lets the user choose a downsampling factor. The function downsample EEG is used to pick every north sample. Baseline removal and notch filtering. These are applied to the working copy of the EEG data, post-downsampling, before updating filtered EEG data. Color-coded event distribution. The Events tab now plots a stacked histogram in plot event distribution, with different colors for each marker code and a separate bar chart for counts. Metadata. The Meta Details tab includes a note that channels 5 to 8 are not providing meaningful data. This complete code should address the FFT error by zero padding and improve overall responsiveness by offering downsampling. Adjust further as needed for your particular dataset or performance requirements.
Okay, can we generate the text-only instructions? Text-only instructions for another developer to regenerate the code from scratch. And don't mention the tabs. In the instructions, yeah, we don't necessarily want the different tabs. Ideally, we want to see everything in one place. And also, we seem to be having trouble with the FFT. So in the text instructions, can we instruct the JavaScript developer to create a standalone function for doing the Fourier transform? A standalone function for the FFT. And make sure we're not including any code in the instructions. We want another developer to do all the code to write all the code from scratch.
Below are the text-only instructions for another developer to rebuild the entire visualization application from scratch. These instructions describe the requirements and design decisions without providing any code samples. Project overview. Develop a single-page web application that loads and visualizes EEG, ORN, marker, and metadata from CSV files. All information should appear on one page, no tabbed interface, so that the user can see the entire output together. The application must perform data pre-processing, downsampling, baseline removal, and notch filtering, and display both time domain and frequency domain (FFT) information. The FFT functionality should be implemented as a standalone JavaScript function. Requirements. 1. File loading and parsing. Use a CSV parsing library to load 4 CSV files. Metadata file includes sampling rate, time offset, channel configuration, etc. EEG data file should contain 8 channels. Note that channels 5 to 8 may contain no valid data. Marker data file contains event markers with timestamps and labels. ORN data file contains 9 sensor channels, accelerometer, gyroscope, and magnetometer. Ensure that all numeric values are correctly parsed and handle missing or non-numeric entries by filtering out invalid rows. 2. Data preprocessing. Subtract the time offset from the meta file from all timestamps so that time starts at 0. Allow the user to select a downsampling factor through a user interface element, for example, a dropdown. The data used for filtering and visualization should be downsampled accordingly to reduce processing load. Implement baseline removal for the EEG data across all channels. This should compute the average value for each channel over the entire dataset or a relevant segment and subtract it from each sample. Implement a notch filter, 50 Hz or 60 Hz, in the frequency domain. The notch filtering should be applied to each EEG channel independently. 3. FFT implementation. Create a standalone FFT function in JavaScript. This function should be independent of other application logic. The FFT function must only accept inputs whose length is a power of 2 and greater than 1. If the data length is not a power of 2, the function should automatically zero pad the data to the next power of 2. Use the FFT function to transform the filtered EEG data for a single channel chosen by the user into the frequency domain. Compute the magnitude spectrum and display it. 4. Visualization. Use a plotting library to create the visualizations. Time domain plots. Plot the EEG data for all 8 channels over time, including vertical marker lines at event timestamps. Plot the ORN data, all 9 channels, on a separate graph. Event data, display the event markers as a table. Create a color-coded histogram or stacked grouped bar chart that shows the distribution of event markers over time. Each event code should have its own distinct color so that the user can easily see how many events of each type occur within given time windows. Frequency domain FFT plot. Provide a means, e.g. a drop-down, for the user to select which EEG channel to analyze via FFT. Plot the FFT magnitude spectrum for the selected channel using the first portion, e.g. first 1024 samples of the possibly downsampled filtered EEG data. Additionally, display the time domain signal after applying the FFT-based filtering, the inverse transform for that channel. 5. User interface and responsiveness. The entire application should be contained within a single HTML page with all visualizations and controls visible on one page. Provide controls, drop-downs, checkboxes, buttons for selecting the downsampling factor, choosing whether to apply baseline removal, choosing the notch filter frequency, 50 Hz, 60 Hz, or none. Selecting the EEG channel for FFT analysis. Optimize performance to prevent the page from locking up when processing large datasets. Utilize downsampling to reduce the number of samples processed. Consider using efficient algorithms or breaking up processing tasks, e.g. via asynchronous operations or, if necessary, web workers. 6. Documentation and comments. In the source code, include clear inline comments describing each section of the code and the purpose of each function. In the project documentation, or within the metadata details section of the application, note that channels 5 to 8 contain no valid data and explain the montage or recording configuration, i.e. that the system may have recorded differentially, resulting in only channels 1 to 4 containing meaningful EEG signals. Describe the overall data processing pipeline: CSV loading, preprocessing, time adjustment, downsampling, baseline removal, notch filtering, FFT transformation, and visualization. Additional considerations: ensure that error handling is robust. If CSV files fail to load, if any parsing errors occur, or if the FFT function receives data that cannot be processed, provide appropriate warnings or fallback behavior. Keep the user interface responsive. If processing becomes heavy, consider adding loading indicators or progress feedback. Structure your code into modular functions to separate concerns, e.g. one module for data loading, another for filtering, and another for visualization. This will make it easier to maintain and update the code in the future. Follow these instructions to regenerate the code from scratch. Do not include any leftover placeholders from previous implementations, and ensure that the entire application is built with these features and improvements in mind.
The user seems to be requesting an explanation of detailed instructions for rebuilding a visualization application from scratch, based on a P300 paradigm. The paradigm involves The application's functionality should include loading and parsing CSV files, pre-processing data, with baseline removal and notch filtering, and implementing FFT in JavaScript. I'll proceed with generating the scripts based on these specifications. The user has outlined the application structure, which includes creating separate script files for HTML, CSS, main.js, data loading, FFT, and plotting. I'll need to ensure that each script meets the requirements for functionality like data loading, FFT processing, and visualization. This error means that when constructing the SVG path, the code is inserting nan, not a number, in place of expected numeric coordinate values. For example, instead of
While it's generating, go check out the website. Everything we do eventually appears on the site. Don't forget to provide your feedback, and I'll see you next time.
The user has asked for help creating a set of script files for a P300 Paradigm data visualization app. The instructions are to generate files from scratch, one by one. Index, HTML, style.css, main, JS, dataloader, JS, FFTUTILs, JS, and plotutils, JS, along with the provided CSV sample data. This is a substantial task, as each file must be built carefully to meet the specific requirements. I'll need to consider the P300 paradigm and how the application will visualize the data when generating these files. The user asks to generate multiple script files one by one, based on detailed requirements for a visualization project. The overall task is to create a single-page web app that loads and visualizes EID, ORN, marker, and metadata from CSVs. The app should include pre-processing steps like downsampling, baseline removal, and crisp FFT visualization. I'll need to use a CSV parser, like PapaParse, for data loading. The response should be structured with separate code blocks for each file, HTML, CSS, JavaScript with proper inline comments. The user has requested that I develop various functionalities for the project, including CSV parsing, data preprocessing, and visualization. The instructions mention using a CSV parsing library, and although I could implement this with built-in functions, I'm assuming using PapaParse via CDN is fine. For data preprocessing, I'll subtract the time offset, allow for downsampling, and apply baseline removal and notch filters. The FFT function will be implemented in FFTUTILs, JS, and I plan to create a simple FFT implementation from scratch. For visualization, Plotly, JS will be included for time domain and frequency domain plots. I'm generating multiple script files as per the user's request, starting with index, HTML, which includes controls, styling, and Plotly integration. For style.css, I'll style the controls, plots, and tables. In dataloader, JS, I'll use PapaParse to load CSV files, create helper functions to process data, and adjust timestamps. The FFT functionality will be implemented in FFTUTILs, JS using a recursive Cooley-Tukey algorithm. Later, I'll move on to plotutils, JS, which will create visualizations using Plotly. Each module will be detailed with comments and structured accordingly for ease of use. In the FFTUTILs, JS file, I'm implementing a variety of essential helper functions for FFT, like checking if a number is a power of 2, 0 padding, and performing the FFT and if using a recursive Cooley-Tukey algorithm. I'll also include functions for handling complex numbers and FFT magnitude calculation. Next, in plotutils, JS, I'll create various plotting functions for visualizing EID, ORN data, event markers, histograms, and the FFT results using Plotly. Each plot function will handle specific tasks, like plotting EID time domain signals, event marker distributions, and FFT magnitude spectra. I will proceed to main, JS, which will handle data loading, user interactions, and eventually trigger visualizations with the necessary preprocessing steps, downsampling, baseline removal, notch filtering. So, I need to apply the notch filter to EID data, which involves performing FFT on each channel, zeroing out the frequency bins around the notch frequency, and then doing an inverse FFT. I'll apply the notch filter to each channel independently, as instructed, but I'll primarily focus on the selected channel for the FFT analysis. This means the time domain EID data, which includes all channels, will show preprocessed data, but only the selected channel will undergo FFT analysis and filtering. For implementation in main, JS, I'll first load, preprocess, downsample, and apply baseline removal. Then, I'll select the first 1024 samples, apply the notch filter for the selected channel, and finally, perform FFT to get the magnitude spectrum. The notch filter must use FFT, and I'll handle this with a function that zeroes out the relevant frequency bins. The error indicates that the function name, 0pad, is declared twice in the same scope. In your code, you already imported a ZeroPad function from FFTUTILs JS. Copy. Later in main.js, around line 129, you define another function named ZeroPad. To resolve this conflict, simply remove or rename the duplicate definition in main.js so that only the imported version is used.